these guides, along with good process, all of a sudden, high performance is easy.
You know, this rethink towards net zero is rethinking a lot of the traditional building enclosure assemblies and building them better.
I get excited, but I also get depressed. I'm depressed because I'm old. And if I was younger, I would embrace this opportunity for this change. I see the young builders, and to me, I get excited for them. Hey, Graham, how you doing?
Good. All right, we're here at wall number 1, which is our vapor permeable exterior insulated wall with airtight sheathing membrane. This represents wall number 1 in the guide here, which is all the details that we put together. And we're going to walk through this wall system here and talk about the design considerations. I'll talk about the constructability, and we'll generally walk you through this and explain, you know, how this works. So we've got a mock-up here that was built by the BCIT High Performance Lab, and we're going to walk through this wall here and talk about the details in the LEEP guides on how this was built. So when we look at it, on this case, we got exterior vapor permeable mineral wool insulation, so it's vapor open, and then we got our house wrap here.
We have another insulation too, right, on the inside, right?
Yeah, we'll get into that. So we got house wrap on the outside, and if we go on the inside of this wall, we've got batt insulation and polyethylene for vapor control. So when we look at this wall, and you know, code minimum in most areas right now is just a 2x6 wall, right? So we got 2x6 wall with batt insulation and poly, you know, R16 to R18 depending on the type of insulation you're putting in there. And so this wall here is in the mock-up is being built on R27. So if we were going to say R35 or R40, we'd have 2 layers of insulation, you know, up to 6. Maybe 7 or 8 inches in some of the higher cases. So we've on the mock-up here, wall number 1, it's vapor permeable insulation. So we've shown a rigid mineral wool, and we'll talk about the cladding attachment later on. In this same assembly, you could substitute this for rigid fiberglass if you found it. Wood fiber insulation, you might have different considerations for the water control, but essentially this is meant to show
permeable
insulations. Yeah, so we want vapor permeable insulations in this assembly here, and because that dictates what we do for the vapor control on the inside. Okay, so with this wall assembly, we've got vapor permeable exterior insulation, and in this case here about 3 inches to get an R27. Okay, and so traditionally, the vapor control in this wall, or a traditional wood frame wall assembly, would have been your polyethylene, typically on the inside.
That's typical, yeah.
Yeah, and as we add vapor permeable insulation, you know, to that wall assembly, it starts to shift, you know, shift the dew point out, essentially in simple terms, but also increase the temperature of the sheathing gets warmer and warmer. And as the sheathing gets warmer and warmer, the need for that poly on the inside starts to decrease, right? So as you shift more and more exterior insulation, you can change the vapor control on the inside.
At some point, you can probably put it right to the outside then, or eliminate it completely, or how does that work?
Yeah, so once you get enough exterior insulation in this assembly here, your plywood, your OSB sheathing will function enough to be your vapor control layer. So for the mock-up here, we've got 3 inches on the outside, and we've kept the polyethylene vapor control layer on the inside. That poly in this assembly could be changed to a smart vapor retarder or vapor retarder paint, and that's covered a bit more in the guide.
The poly's kept here because this mock-up doesn't have enough exterior insulation on it to consider taking it out of the equation yet.
It's close, yeah. And if you want to be a bit conservative, you can leave it in. And so with permeable insulation, you can leave that vapor barrier on the inside fairly safely. When we get into other assemblies with impermeable insulation, that's really where we start getting into changing that.
So having a permeable insulation, let's say I want to leave the poly. I want to put the poly, no problem, right?
Yeah.
Okay. So I can just leave it no matter how much I put.
That's right.
I can leave the poly without detriment.
That's right. And one of the benefits of this wall assembly 1 here is that you can keep your traditional practices and you just add the insulation without rethinking potentially your vapor control. And then if you're already using an exterior air barrier approach, just keep building off of that.
Yeah, so I kind of look at it as the plywood's like my skin. So if I go outside in the fall, I wear a thin sweater. And if I go outside in the winter, I wear a thicker sweater.
Yeah.
just to be comfortable. So
Yeah, and
that's kind of a neat concept.
yeah, and the neat thing about this too is when we look at near net zero, if you're building to a near net zero level or passive house level, you know, you're going to have thicker amounts of insulation. If you're building to code minimum, or if you're building on your way to net zero,
Yeah.
it's just a matter of changing 3 inches to 6 inches or 1.5 inches, whatever it is. It's just adjusting that insulation, but everything else stays the same.
Yeah, so you can master your process.
Yeah.
Without risks with the permeable insulation.
That's the idea with the guide and the mock-up that was prepared here, is that this represents, you know, any sort of thickness and details that come with that.
Yeah, starting point.
Yeah.
Okay.
So when we look at mineral wool, vapor permeable mineral wool as an exterior insulation, the insulation itself is water repellent, but you notice you have gaps and other things, you know, flashings and other components tie back into the house wrap here. So from a water control standpoint, we're not going to rely on the face of the mineral wool to keep the water from getting into the wall. We're still going to have a water resistant barrier at the backup at their sheathing. So just like we would build a typical 2x6 framed wall where we have house wrap on the outside of that wall as our water resistant barrier, we're going to keep that water resistant barrier behind the insulation in this case.
And then tape it and make it the air barrier also.
We'll get into the air barrier details in a minute here, but from a water resistant barrier standpoint, we're going to have this, and all our flashings and details are going to come back in there. And so when you look at the guide, all the details take all the flashing and the water control air back to the wall system here. Okay, so you do all your water resistant barrier and air barrier details first, then you put the insulation on. And so you're managing and flashing and everything's detailed back here.
So same process as we're building now.
Yeah. And so the unique thing about mineral wool is, you know, you spray water at this, it doesn't tend to go through it. It's hydrophobic. For water to get behind it, it sort of has to find a detail that can, you know, sort of run back through, and then by diffusion it can dry out.
Well, and if there's enough moisture for whatever reason, there is a free draining ability.
That's
with
right.
This type of
and
insulation.
it can drain out. Or it can also dry out by diffusion, and that's what vapor permeable insulation means, is you can dry through it. And that's one of the, you know, in a wetter region, why people would look at this approach. So, so we got our water resistant barrier at the backside here, and that's where it makes sense to put it. When we look at air barrier options for this wall, okay, the insulation itself isn't air impermeable, so we can't use the insulation as an air barrier. But we already have the house wrap, which we know we can make an air barrier. We can make the sheathing an air barrier. We could also use traditional approaches like polyethylene or drywall on the inside to use that as an air barrier approach. So you have lots of choice.
And we can have both. Yeah. 2 air barriers, right?
Yeah, that's right. And generally, as you add more exterior insulation, it's safer to shift the air barrier further out. And it's talked about in the guide and the insulation flow chart there. As we add more exterior insulation, the air barrier shifts from the inside in traditional approaches to the outside. And we'll get into some of the nuances of that detailing later on. But for the purposes of the mock-up, looks like we've got an air barrier. This isn't sealed up here because this is, you know, tying in here. And we'll walk through some of these details in here in a minute. But the air barrier approach is our house wrap. So let's walk through the air barrier strategy for an exterior air barrier on this wall assembly. We're going to start down here at our foundation. We got in the case of the mock-up here, we got an ICF foundation. We got concrete here. We got the insulation on the outside of the ICF. We got the waterproofing, the peel and stick that's been applied to the ICF. And then the air barrier, we're transferring the air barrier all the way through this assembly from below grade all the way into in the mock-up here into the attic. So we've got peel and stick flashing, we got peel and stick here, and then we've taped the house wrap, right? We taped the house wrap to the peel and stick, and then every lap in the house wrap gets taped to the vertical and horizontal seams. The air barrier comes into our window here in our flashing. We tie in the air barrier into the backer rod, in the sealant that's applied over backer rod through our window, along the jambs with the sealant into the head. And then we've got the air barrier transitioning up here behind the detail here. So we've lapped and taped this. And then we're transitioning in this case here on the inside, we've got polyethylene as our air barrier, right? On the ceiling. And so we need to transfer the air barrier through this interface. All right, so we've got our house wrap made as our airtight element here. The challenge is we have now the air barrier sealant, which is still polyethylene, traditional approach with more insulation in there. So we need to transfer the air barrier through the top plates, okay? And this is one of the trickiest details when you go from an exterior to an interior air barrier approach. If you don't do this right, air just comes up through here and into your attic and out. So it's a big point of leakage. And so there are a lot of different ways to achieve this air, the air barrier transfer through this top plate. So we got, essentially we got to go from, what's being shown here is we've got the house wrap and then we've sealed that against some caulking along the top of the walls that's compatible with that house wrap. And then it gets gasketed by the insulation. But the challenge with that is we need to then transfer through this plate. So there would have to be some forethought put into putting sealant in between here and then to the inside to transfer through the top plate.
So yeah, so the framers would have to put this in for you, and then anytime you had a joint, you'd have to seal between that joint. So
yeah,
there's some sequencing and care needs to be taken in order for that to be as successful as one would like.
A traditional approach is where people put, they've put a layer of house wrap between as a pre-strip. The problem with that is it gets ripped and torn and
corners. What about at the corners when you're locking your plates and all that and trying to see all that?
Very difficult to get to the air tightness levels you need for net zero. And this is where it needs that rethought to the approach. And that's why you got this approach here with sealant, which is, you can.
It shows the intent.
Yeah, the intent.
It shows the intent.
Yeah, and the idea, there are other ways too. You can use tape. Especially tape that sticks to wet wood if this happens to be wet, or peel and stick along the top here. So something that allows you to make that transfer from the inside to the outside
through that top plate.
Yeah.
And I think when you do this top plate thing, you also got joints in that plate that also need to be sealed. And I think it's a three-dimensional world.
Yeah.
And the two-dimensional approach, I think, is sometimes mistakenly employed to not a great result.
And this is one of those details where inspecting and reviewing it as you're putting it together, and you can see if you can see a hole, then you need to seal it up.
Yes,
right?
And that's having that person on site who's your air boss or your envelope reviewer.
So James, how do we transfer the air barrier from our house wrap to the poly on the inside of the top of this wall assembly?
With this assembly, we had the plywood sheathing with the bead of sealant at the top plate to make that connection, and then the air barrier was set into a bead of sealant in the plywood. So air barrier connects to sealant, connects to plywood, connects to sealant, connects to plate.
So
you then have to run the sealant on each of the joints of the plate.
Yeah.
Alternatively, you can use a high performance tape, bring the tape from the plywood onto the plate, tape the Tyvek air barrier or similar to that tape all the joints, and run your acoustic seal and run the polyethylene air barrier, vapor barrier, and the sealing into that acoustic seal.
Nice.
It's a very clean way to go. It's a good alternate. You don't have to involve the framers.
Yeah.
You're not weather dependent because the tape works on wet wood. And if it's raining, the framers putting sealant in there is not going to be your best bet.
Yeah.
And so that's another way of handling
A little more weather friendly if you use the right tape.
Yeah.
How do builders, what's the saying they can do to remember that?
The saying they can do, the tape to the tape.
Yeah. How do you do it?
What do you mean, how do I do it? Tape to the tape.
Tape to the tape to the tape?
Tape to the tape. You put an initial tape before the trusses come. When the air barrier comes up, you tape that air barrier to that tape.
Tape to the tape.
The best part about that, and now I'm going to go off on a little bit here because I can't help myself. Okay? So the best part about that is when you use that series and that system, various parts of the building, you'll see this magical tape. And people want, what's their little pieces and rings of tape here and there?
Yeah.
Those are your transitional points. What happens when you do that, by osmosis, people understand the air tightness and the planes of air tightness because they're just taping to the tape, not knowing why. Once explained, light bulb.
Perfect. You know what? So James, tape and air barrier transitions you can see instead of sealant have other benefits.
You walk up to the building and you see this white ring around the top and you go,
Done.
They got a plan.
Yeah.
I got a plan. Tape to the tape.
This is hard to inspect, hard to see.
I've done this. I'm trying to review if there's sealant there. It's blind seal. Avoid blind applications for high performance.
Great.
So this mock-up demonstrates the sealed house wrap air barrier approach because it's seen as cost effective. It's something that most builders are already pretty familiar with doing. And so this mock-up here takes us through the details from below to above grade, through the window, through details. The guide shows penetration details, and then our tricky transition detail here at the roof to wall interface.
And I find sometimes that Yeah, the guide shows it and everything shows it, but when you get to site and you're looking at this big wooden box here that you're making, and you go, okay, I'm doing an air barrier.
Yeah.
Just connect the dots and make sure that one connects to the next, and you can be successful. But when you're first trying to establish this, it can be a little bit confusing. You know, we have garages and stuff, which semi-conditioned space, and how you transfer it across the back wall of a garage, your air barrier, and there's a whole bunch of stuff that needs to be considered. But if you connect the dots, as they say, you can do what's necessary through standard materials and process and work that into your program and have an airtight building.
Yeah, and this approach, you know, like you talk about garages and things like porches and balconies,
Projections overhead.
we need to pre-strip with this, right? And so there's there's definitely that sequencing in the air barrier that comes into place there. And of course, you know, there's other ways to do this as well. In this approach, we could use plywood as the air barrier. We could seal that from the outside with tapes. We could use self-adhered membranes, which are, you know, basically sticky versions of house wrap. We got liquid applied membranes and joint treatments. All these approaches can be done on this outside face here, depending on, you know, what your budget is, your ease of construction. You know, some of these products like self-adhered membranes make all this taping and lapping a whole lot easier than
it truly is a system. What I find interesting is through your talk here that you can use wood as part of your air barrier system.
That's right.
You can't blow air through a 2x6.
That's right. Yeah. So you're using wood where it makes sense to make that air barrier transfer. So you don't need a piece of plastic going through there. You know, like people in the past may have stripped in a piece of polyethylene or something on the top here.
The trusses come then, and it can be a little bit of a problem.
You fall off your roof, right? So got to keep safety in mind too. So
interesting.
So as we look at this wall assembly, and you know, starting with our sort of code, you know, sort of level here in R27, you know, R40 out a bit more, all we're doing is adjusting this. We're keeping this as a 2x6 in this case here. You can actually go back to a 2x4 and actually have more exterior insulation. So if you don't need 2x6 framing for the bat, and structurally you can get away with 2x4. 2x4 actually makes a lot more sense.
Most homes 2x4 construction is structurally adequate.
That's right. And 1 and 2 story homes, even, you know, taller, you know, you essentially go back to a 2x4, and then you have more exterior insulation, because you're going to end up with a thinner wall, a higher R value wall with that 2x4 instead of the 2x6, just because of the less thermal bridging that you have all the way through the wood frame assembly.
To me, and I've talked with builders stuff, is just think of it as a new plywood, because everything you're doing on this insulation is what previously you would have done on your plywood. You mount your flashing on it, you mount your strapping on it. It's just like you would do before. Putting insulation on the outside. It's a neat way to look at it.
So when you look at exterior insulation, the first question you often get is, how do I attach my cladding through my exterior insulation to the backup wall? Rigid insulation, no matter how rigid it is, it's not something we're going to be screwing into and attaching our cladding through it. So we need to attach the cladding back into our framing, potentially even back into the studs, depending on the loads of our building. And so when you look at approaches that are available for this, you know, one of the simplest, and what we found works really well for residential wood frame construction, is you just use long screws through the vertical strapping that we've got here to back into your studs, or if you want to design for into your sheathing, to then attach your cladding to this strapping.
And that's right. And one of the things that I'm always hit with is, well, it's too soft. And so when I put my screw in, and I put a screw into here, you can see the screw has a bugle head. So that means that force necessary to sink that bugle has to get transferred through the insulation, which doesn't make any sense because you never install things stressed, right? So if you just simply take a countersink bit, you make a bugle shape. You put the screw in, you can sink the screw and cinch it right to the strapping without it moving. There's actually a benefit, is you can adjust the wall. If the framing's a little out of plane, I use typically a 5-foot rod net when I'm doing this, so I can do just random checks. And when I find framing's not plumb, which happens occasionally, that you can actually square up and straighten up walls using this approach. So it's entirely doable, and I think misunderstood by many, that you can't do this. And I guess you in the research world have done all kinds of studies that you can hang what you like on that.
Yeah, that's right. Testing we've done, you pretty much hang your pickup truck off the side of your off your insulation now. So the way this works, and you've got these. This is cut for the mock-up here, but your vertical straps, 8-10 foot straps up the wall, and you just put screws in every 8 to 16 inches on center, depending on the load of your cladding, your wind load, where you are. But typically every foot you're putting in a number 10 or number 12 screw and into the strapping, and then your cladding we get then nailed or screwed or however you attach your cladding traditionally onto this strapping.
These screws have to hit a stud, right? Is there anything else we can do with that?
Generally designed to hit the stud, and the guide talks about how you would do that. There's many different cases here. The backup framing might be different. You might need straps in different positions for different types of cladding, for example. Generally, you try to line these up every 16 inches on center to line up your stud pattern, but there are times when that's not going to be possible.
Right.
In many cases, you're going to get reduced, capacity of that. But in most cases, for lightweight claddings, it's not that big of an issue. But as we get into heavier claddings or higher loads, what you can actually do is you can change your sheathing at the design stage or construction stage. Instead of using 1/2 inch, go to 3/4. And with 3/4 inch sheathing, the testing that's being done has shown that with 3/4 inch sheathing, you actually don't need to hit your studs. 3/4 inch sheathing, we found the same pull-out resistance for this as you would through 1/2 inch sheathing and you're ending into your stud by about 1 inch.
Right. So by putting the 3/4 sheathing on, I can now set my straps where I need to.
Yeah.
Without having to, perhaps by backing to the backside or being concerned that I have reduced areas of strapping. So my actual install process
A lot easier.
could be accelerated by the freedom of install, if that makes sense, where I can freely put them as long as I keep under Part 9 my 80% net free area. I see we have 3-inch straps here, which at 16 inch on centers provides 13 over 16, 81.25% net free area. So then you're okay to do that. So you can, when you have details in that, you put more straps in to suit it, but the average overall still at 80. I really like the 3/4 inch plywood that you mentioned there.
Yeah, so you notice here that we are using 3-inch straps, which is intentional. So we have the maximum sort of surface area here for lining up cladding and trims. Conventional rain screen strapping would have been 1.5 inches or so. That's not quite enough area here to attach into sometimes. So that's why 3 inches is preferred. The other thing with 3-inch on this approach is you get more bearing area when the strapping compresses into the insulation, and so you actually get more load capacity. And in the way this approach works structurally is you got long screws through the insulation, and you actually create a truss, right? And you're creating a truss with those screws that are installed horizontally. Is you've got your vertical strapping here, and you got your long screws that are going through every 12 inches or so. Those are horizontally
Tension member.
Yeah, and that screw becomes your tension member, and you got compression into your insulation, and you got some friction here that's all also holding more stiff. And so essentially what happens is you got this truss, which now you're hanging your load off of this vertical strapping on the outside. And so a lot of testing has been done to prove out that load carrying capacity, and you can hang a whole lot of weight off of that, more than you need for any sort of conventional cladding systems. And it's compressed enough in there, and then it's held into place, and it provides a rigid substrate for your cladding. And so your cladding fasteners are only going into this plywood there. Plywood tends to be preferred over dimensional lumber just because it doesn't split as much. You can use 1x3s as well, but it's not necessary. And the guide goes into more detail about pressure treatment and where you might need that, and choices for the lumber that you have.
Okay. I looked up for fun on the 11-pound density mineral wool. It's 586 pounds per square foot compressive resistance.
Oh, compressed, yeah.
And it was like, I was surprised. And now you take that over a uniformly loaded wall.
Yeah.
On a 12-pound per square foot cladding.
Yeah.
Kind of a no-brainer.
Yeah, and so one thing to note with this insulation, this is a rigid mineral wool, and we're familiar with semi-rigid mineral wools that you use for bats, and even softer insulation you use in commercial applications and cavity rolls. This is definitely a more rigid product. And that rigidity is what allows this to be done. You're not going to be putting bats that you're squishing into this. Yeah.
no.
And when you install these, you're getting minimal, compression in there. It's just seating into place into the face, and that's what you're looking for with that install.
And it's interesting you say that, because when you do install them, they kind of seat a little bit, right?
Yeah.
And even the data sheet that I looked up said, 586 pounds at 10% compression,
Mm-hmm.
right? So once you seat that, you're utilizing its full ability to resist loads.
Yeah.
And so it works very, very well.
Yeah, and another thing too is you don't need to, screw it in super tight. You don't need it to compress in. It just needs to be snug. Just seat it,
seat it. So
yeah.
boom.
Yeah.
And then if you need to, you can bring it in a little bit,
Yeah.
or you can bring it out a little bit as needed.
Yeah.
It works really well.
Yeah.
So
with this wall, with wall number 1, we've highlighted some of the unique detailing considerations you have, and most of them come in with the roof to wall air barrier detail. You got to get the exterior air barrier to the interior, but also our window details. Unique detailing with exterior insulation typically comes up when you start looking at your window details. Biggest question is, okay, where can I put that window into the wall? How do I install the window? What do I do for window flashings?
penetrations.
This becomes the hardest point. And once you figure this out, then everything else, all the other details you have, become a lot easier. Okay, so with the window installation details, first off, there's a whole bunch of different windows you can buy. There's hundreds of companies of windows you can buy across Canada, and so it's looking at fundamentally, when you look at the offerings of windows, we have windows with that are installed with clips, or on the inside, or with flanges.
Flanges,
Right.
yeah.
Right? And so we've got flange and non-flange windows. Okay? And so what we've shown in the mock-up here, and the reason we've shown it is because it's easier to install and it gives you more flexibility, is a non-flange window. If you wanted to put a flange window in here, however, the guide walks through a few more details, it becomes a bit more complicated. But a non-flange window with exterior insulation becomes a whole lot more flexible with how you get to where you get to put it in that wall and how you flash in detail.
As long as the glazing is structurally supported,
that's right.
you have that flexibility.
That's right. And so with this wall system here, we've got our non-flange window, and it's bearing still on the wood. Okay, and so what we've done with this exterior insulation detail here is we have the window sitting on the structural framing. You can't sit the window out on the insulation without putting some sort of structural connection out there, support. And so the easiest way to make that transition from current practice to exterior insulation is you keep the details very similar to you had in the past. We're using a non-flange window here, which it's bearing on shims at the base, and then we're on the inside we're actually using clips. And this particular detail, and there's a number of different iterations of this, we've shown a backer rod and sealant here, and that sealant is creating that air and watertight layer. Common practice in many parts of Canada is I'll use a back dam, whether it be a wood back dam or a aluminum or a metal angle, shiny 90 type thing, where you have that peel and stick coming up on that angle and then sealing that. And that provides
some windows actually require that as part of their install method.
That's
okay?
right. Yeah.
And so you have to put that angle for attachment.
So when we look at our options for window sealing, we've got option A here, which is backer rod and sealant, and option B, which is a sill angle. And option A as well, we can also slope the sill, so we can improve the water shedding of the sill by providing a bit of slope for drainage to take that water away. But if you look at option A, we got backer rod and sealant at the inner perimeter of the window frame, going from the sill all the way around. It's nice continuous seal, providing our air and water control. Option B, we have a sill angle, and the idea with a sill angle is we've got aluminum or a steel angle on the inside. The waterproof membrane, the flashing membrane, runs up the sill angle, and then we have sealant between the flashing membrane and our window frame, and then the window frame is typically screwed, structurally attached, so we don't have to put fasteners down through the sill there. There's also variants of this where you could have a wood sill angle, or the membrane comes up and you can seal in between depending on your structural attachments. So these work really well. And a lot of when you look at the LEEP wall systems with exterior insulation, they all show a non-flange window, and that's because it simplifies a lot of the detailing that we run into with exterior insulation. It allows that membrane to transition right out at the height of the sill. When you get into a flanged window option, so a window flange would be where you attach your window on the exterior side of your wall with a flange that runs around the perimeter. The challenge with a flange window is we need to provide drainage from that space behind the flange and the frame out. And by putting that flange there, it actually interferes with our exterior insulation. We either have to pull the insulation down a bit and add another membrane below, or we look at draining through or shimming off that flange to provide drainage in behind. Likewise with the non-flange window, you seal it with a perimeter seal, like on the inside. You could have a slope seal here as well, just a bit more complicated with when you have a slope seal on the flange, but it still can be done. And then a perimeter angle, just like before as well.
I got a question. So the window's in its placement. Is there any advantage to putting it in the inboard side of the thermal plane, the middle of the thermal plane, or the outside of the thermal plane? Or are you just worried about getting it structurally supported?
Yeah, so great question. So, traditional approaches on thinner wall assemblies, the windows typically with flanges would be more towards the outside, and rebate would be sort of sitting around where it is right now. As we add exterior insulation, you got the effect now that you start getting these deeper spaces on the outside that you have to flash and trim, right? And so if you want to create that sort of traditional look where you have the window flush with the cladding, you need to push that window out, which means then you need to build a buck.
So thermally, it's not the difference. It's aesthetically.
Well, aesthetically to start, right?
Okay.
So usually driven by aesthetics, in or out, and you get that look either way by pushing it in or out. Just with exterior insulation, you're going to have to add some support for that. But thermally, the best place for this window is somewhere near the middle.
Sure.
You want to line the window
Makes
up
sense.
with the thermal continuity. And in this wall, we've got insulation or cavity insulation out here. So that's roughly in the middle.
Fair enough.
And a thermal standpoint, that's optimal.
Yep.
And so the details in the guide are showing simple details where the insulation stops around the window perimeter.
Around the rough opening.
Yeah, and if you look at Passive House and actually some net zero projects, you'll start to see in some of their window details is they're going to encroach the insulation over the head, maybe an inch or two, and maybe at the sill and the jamb. And so that's not shown in this guide, but that's where we're going next.
Down the road.
Yeah, down the road, yeah. So if you start seeing details where insulation's like pulling over the frames, that's what they're doing. And what they're trying to do there is reduce this flanking thermal bridging that's occurring through here. You got, R27 here, and you got a window with much less, thermal performance, but then you've got all this wood framing. So you're trying to reduce that thermal bridging at these interfaces.
Right.
Yeah.
No, that makes sense.
So window details really highlight a lot of those considerations with exterior insulation, where you put the window, how you seal the penetration. This is our plane of air and water tightness back here. We go in the window, back out. And so really when you start getting into all the details, it's about sealing and getting back to this location here. And in the case here, they got the insulation on the outside providing that thermal
So
buffer.
nothing much has really changed. You still frame your 2x6 wall.
Yep.
You put on your barrier system, be it air and water,
Yep.
on the outside, taped and shingled and all that kind
Yep.
of stuff.
Same vapor barrier on the
And
inside. Yep.
you put on the new sheathing, which is now your insulation, and you strap it and clad it. So
Yeah.
the process is pretty simple.
Mhm.
There's a couple things that I see from a constructability perspective that could be challenging.
Yeah.
I see a membrane coming out over my window,
Mhm.
or out of my window here, that's going to be on long before this comes on.
Yeah.
And I'm just wondering, there are alternate ways to adjust this, I suppose.
Mhm.
I think the guide touches on that a little bit.
Yeah. So with window sill details here, usual sequencing is, the house wraps on the windows in, and then insulation's going to come in later on. You're not going to put the insulation in
Right,
the
or
windows.
even the starters around the window,
Yeah.
you go to lock up, that kind of thing,
Yeah.
depending on
And
how
so
you're doing her.
the way the detail is shown in the mock-up here, we've got an extra piece of peel and stick going over this insulation. And the reason we're showing that is we don't want to dump water in behind here if we can avoid it.
No, it's a planned drainage path, and
Yeah.
I think you're supposed to send the water to the exterior.
Yeah.
Somewhere in the code it mentioned something about that, right?
Yeah, you really don't want to dump water in any type of exterior insulation behind it if you can avoid it. So what this is supplemental flashing membrane that's below the window. Now, this here in this particular case here, is going straight across the top here. You could also drop this insulation down and do a detail here where you actually
And then just
transition.
put a little insulation plug back in.
Yeah.
Yeah, that makes sense to me, and I have done that detail based on some of the alternates shown in the guide, and found that it works out quite well.
And if you have flange windows, if you really want to use a flange window with this, that's going to create the flange and that attachment point, and you can't, you know, think of sequencing wise, you don't really want to pull that insulation up to that flange for drainage.
Yeah.
And so you actually, it's preferential to actually drop the insulation down here and then peel instead.
Probably required because there's a flange in the way, so
That's right.
you're not really going to have this membrane sticking out. So I just thought I'd point that out, that, you know, it's about the intent.
Yeah.
This is the mock-up.
Yeah, that's right. Okay, so when we get into window sill flashings with exterior insulation, we have a few different options. Okay, so if we look at the baseline preparation, we have a 2x6 wall with our self-adhered membrane at the sill, our flashing membrane. When we add the exterior insulation, we don't want to dump the water behind the insulation. So we actually want to flash from that rough opening and the prep and the self-adhered membrane there over the insulation. And the easiest way, and if we don't have if we have a non-flange window, is we just have an extra piece of membrane that goes over top of the insulation down. You can cut the insulation on the slope and out. If you have a flange window, however, that flange gets in the way from that direct transfer out, and so you have to go down and out. And this adds, of course, complication. And then there's a large space where you don't have exterior insulation unless you take a small piece and cut it and put it in place, which is good practice, of course, considering the drainage that you're going to get in there. There are scenarios, however, where, you know, the amount of water that you're going to expect behind that window might be pretty low, or you might have a cross cavity flashing, you know, a foot or so below your window, say like a floor to ceiling window. You might have a cross cavity flashing anyways at a floor line, and therefore you could just drain the window down behind that insulation if it's drainable, and then out, especially in the wall assembly where we've provided drainage. That's only really recommended if you have intended for that, but essentially it allows you to go down and out at that location. So with windows and windowsill options, we have lots of options, and the important part is getting the water that does get in out and draining it where you want it to go.
This wood member here that's around it, that's installed for what reason?
So when you look at your trim details around your windows, you need to attach this into something. So in this particular mock-up, they've put in a piece of wood blocking, intermittent wood blocking here to provide a nailer for this wood trim. If you had metal trim, you could tie it into the frame, or you wouldn't necessarily need that. But this wood intermittent blocking here is put in there intermittently. It's not continuous, to pick up your trim pieces.
Yeah, I can see here that also using the side of the strapping. So you actually have two attachment points that you can attach. You have a drainage at the head here?
Yeah, that's right. Yeah, if you look at this detail in here, this is just in the mock-up. You got bug screen here, you got this piece of strapping here, it's just piece put in there, and you got drainage in behind there.
With a little gap right here, so that you have a backup underneath.
Yeah, and this window head detail, you know, this, when you look at this, you know, when you look at our window head detail, this mock-up is being put together for a trimmed detail. There's about 4 or 5 different ways you can do this in terms of sequencing, and it's going to depend on how you sequence in, if you do pre-strip or the full house wrap and cut it out. And so the idea and the whole, you know, fundamental for designing is, you know, from a water shedding standpoint, any water that's getting here is drained out. If we didn't have the flashing here, and say we didn't have a wood trim, we could do it down here, right? And so the reason we have the flashing here on the wood trim is to protect the top of the wood, make that transition from our fiber cement to our wood here. We have a bit of ledge, so that flashing flashes out the wall. So this is flashing out the back as well as the face here. But you could also move all of the flashing down to here and drain out that as well.
Okay. So from a constructability standpoint, get the membrane, your air barrier and water resistor barrier on, do your review, make sure that everything is installed as should be.
Yeah.
And one of the things that I like is, and should be thought about, is when you place your straps, I guess you need to kind of have a plan, because you're not going to want to pull that out again and put a new one in, because you're going to leave holes in your air and water resistor barrier. So if you're going to do that, then you should repair it if you're going to move it over.
Other testing that we've been doing is actually looking at, if I screw through this insulation into my house wrap, which is air barrier,
Yeah.
am I putting a big enough hole in that air barrier to cause a problem?
Are you?
Well, when I screw right through, and if I leave the screw in, that hole is gasketed and it's compressed by the insulation and the house wrap in there. And so that actually is not a problem.
Right.
However, if you pull those screws out, you end up with these little holes, and enough little holes there will cause an issue. Okay, so if you put the strap here and then needed to move it, say over here, because you put it in the wrong spot, you'd have to pull this out, then you'd have to pull the insulation out, tape the house wrap, which is not hard to do, but you have to do it. And so the worst thing you can do is just move these without, or the easiest thing, you know, the simpler approach is just leave it in place and add another piece of strap.
Yeah, and there's a couple ways to do that. So if you had the 3/4 strapping, or plywood, sorry, maybe just leave it and move it over a new one. Just
Yeah.
leave it, no harm
Yeah.
done. The other thing that I have done is I have a little cordless sawzall, and I just cut the heads off the screws. Okay, and I just take the strap, I leave the screws in.
Oh, yeah.
They seal it off, you cut it so there's no issue, I move it over, and I'm done. So I
idea.
always have the little cordless sawzall with me for the oops, I made a boo-boo
Yeah,
moment,
yeah,
okay? So that's not really a problem. The other thing that is really, really cool, and as I understand, is you can actually improve your air tightness using a sandwich approach that many of the LEEP walls actually utilize to the advantage, right?
Yeah.
Where the air tightness increases
Yeah.
by sandwiching this membrane and
Yeah.
applying basically a pressure gasket over the surface.
Well, what's really neat is we've been testing a lot of buildings with, say, house wrap as an air barrier in both exposed cases where it's just behind strapping or cladding, and in cases with exterior insulation. We're seeing large buildings now with exterior insulation sandwiching house wrap there coming in consistently tighter than passive house, 0.6 ACH and lower, very consistently, with good details and that
sandwich membrane.
sandwiching. Yeah, and when it's not sandwiched, we see results all over the map. But if you do a really good job, you can also get to similar levels. The sandwiching makes your life easier and it keeps things in place.
So as far as any challenges with this wall, I'm not seeing a lot of challenges even from the basic sequencing and skills that are currently on site. We're doing this now.
Yep.
The code says you need a plane of air tightness, so make a plane of air tightness as you do. This insulation is very easy to install because you already put the plywood on, so it's kind of like just putting another layer on and then use this for attachment. So I don't see too many challenges. I think the skill set out there can easily manage this wall number one.
Yeah, this is, you know, when you look at wall number one, it is a simple step forward, you know, to go using exterior insulation with traditional backup details. You do have complication and new details, I should say, around windows and penetrations, but it's not overly difficult. It requires retraining and rethinking about the way you do these things, but it puts you on that path, right? And so whether you're doing 2 inches or 6 inches, it's the same. So you learn on the simpler jobs and then extrapolate.
Start with what you know and just add a little bit to get a little bit better.
Yeah.
Thank you.